Okay, this is a video to review graphing polynomial functions. So let's start with, given the equation, we will graph the polynomial. So let's say we were given the equation x minus 1 squared, x plus 2 to the third, x minus 4. And let's put a 1/16 in front. So by doing this, I'm going to look at a couple things. The first thing I'm going to look at is the degree. This is squared, cubed, and then to the first. So if I add this together, that'll be 6. So the degree is 6. And the leading coefficient is positive, so that means that my end behavior is going to be both up. The next thing I do is I'll do my y-intercept. So if I put 0 in for x, I get positive 1 times 8 is 8, times negative 4 is negative 32, and I'm going to divide that by 16. So I get my y-intercept to be negative 2. Next, I'll plot my zeros. I have a 0 at 1. That comes from this. I have a 0 at negative 2. And I have a 0 at 4. So the behavior at 4 is I'm going to pass through, I guess I should put my behavior here. So I'm going to pass through like this. And then I'm going to bounce at 1. So I'll come back up, bounce. Now I have to come down and hit the y-intercept. And then I'll wiggle through negative 2 because this is a cube. So I'll come through and wiggle. So just to review the end behavior, as a refresher, if it's in factor form, we're going to add the exponents. So I would add 1 plus 3 plus 1. That would be a degree of 5. So my end behavior would be down, up. If I put a negative in front of this, that would switch my end behavior to up, down. If I take this x away altogether, and I just had x plus 1 cubed x minus 1, then that would be to the fourth, so that would be both up. And if I put a negative in front here, then that would be both down. So that's if it's factored. If it's not factored, you look for the highest degree. So 3x cubed minus x to the fourth plus 1. Here, the highest power is 4, so the degree is even, and the leading coefficient is negative. So that would make the end behavior both down. So it just depends on if it's in factored form or not factored form. The other thing we have to be able to do is come up with the equation given the graph. So I will say that this is a wiggle, so I'll make this x plus 1 to the third. And then this is a bounce, so I'll make this x minus 1 squared. There are many graphs that have these characteristics. We have to figure out the coefficient in front to make sure that it goes through the point 0, 3. So let's pick a letter and then plug in 0, 3. So b 0 plus 1, 0 minus 1, and set that equal to 3. So this is 1 times 1, so b equals 3. So my final answer would just be 3x plus 1 to the third, x minus 1 squared. There's no need to multiply that out. Last, let's do one where the leading coefficient should come out to be negative. So if I do this one, I have x minus 2 squared, this is a bounce. This is x plus 1 to the first. This is x plus 3 squared. So what I saw for my leading coefficient now, I want to make sure that I get b to be negative because of my end behavior. So plugging in 0, -2, I get b -2 squared 1, 3 squared equals -2. So this is 4 times 9, which is 36. So I get b equals -1/18. And that's exactly what we would expect, because we expect the leading coefficient to be negative. So my final answer, basically, instead of writing b up here, I would just write -1/18, x minus 2 squared, x plus 1, x plus 3 squared. And that would be my final answer for y.